devices and the system using drivers, ensuring smooth input and output operations. These core functions enable the operating system to effectively coordinate hardware and software resources on your computer. Understanding these functions helps appreciate the complex operations, ensuring seamless user experiences on digital devices. Operating systems are essential for managing hardware and software, creating a stable environment for applications to operate smoothly. Key functions of an operating system. Operating systems handle tasks like memory management, process scheduling, and managing files, ensuring efficient system performance and user interactions. Types of operating systems. There are different types of operating systems, including desktop OS, server OS, embedded systems, and mobile operating systems. Basic components of an operating system. Operating systems consist of kernel, user interface, and system utilities, each playing a role in managing system operations. Examples of popular operating systems. Popular operating systems include Windows, Mac OS, Linux, Android, and iOS, each catering to different user needs and devices. How operating systems work. Operating systems operate by interpreting user commands, managing resources, and ensuring applications run without conflicts or interruptions. Conclusion. Understanding operating systems enhances our ability to interact with technology, highlighting their importance in everyday computing tasks.
Welcome to our video on essential computer concepts, where we explore threads, system calls, and more about operating systems. A thread is a lightweight process that allows a program to perform tasks concurrently, enhancing performance. System calls act as a bridge between the program and the operating system, enabling the request of various services. Booting is the critical process of starting a computer, loading the operating system into memory, and preparing it for use. Let's look at popular operating systems. Windows is the go-to for personal and enterprise PCs. Mac OS powers Apple's Macs, offering a simple integrated user experience. Linux, known for its open source nature, is favored in server environments and developer support. Mastering operating systems is key to maximizing the potential of computer technology in varied applications. System calls are essential for file operations, including opening files, reading data, and writing information to storage. Process control system calls allow the creation and termination of processes to manage application execution efficiently. Memory management involves system calls that allocate and free memory as needed by applications to optimize performance. Operating systems handle multitasking by enabling multiple applications to run concurrently without interference or data loss. During context switching, the OS saves and restores states of processes, ensuring seamless multitasking and efficiency. Resource allocation in an OS involves distributing CPU time, memory, and I/O devices based on the needs and priorities of processes. Security in operating systems is upheld through measures like user authentication to safeguard data and maintain resource integrity. Operating systems manage communication between the CPU and peripherals like printers and keyboards, facilitating efficient data exchange. of system calls include file manipulation, process control, and device management, crucial for application operations. In this video, we'll explore the vital role of process management in operating systems, focusing on task scheduling and execution. The kernel efficiently allocates CPU time using algorithms such as round-robin and first-come, first-served. Moving to memory management, the system tracks memory allocation, ensuring each process has sufficient RAM. By implementing paging and segmentation, it optimizes virtual memory utilization for better performance. File system management oversees files and directories, enabling smooth read and write operations and storage devices. It employs file systems like NTFS and extension to organize and manage data effectively. Lastly, device management uses drivers to translate OS requests into commands for hardware control. Operating systems act as crucial intermediaries between computer users and hardware, enabling application execution and resource management. The boot process begins with the system firmware, like BIOS or UEFI, initializing hardware components. The bootloader, a small program, loads the operating system kernel into the computer's memory. Once loaded, the OS kernel starts, initializing system components and managing hardware interactions. The kernel, central to the OS, efficiently manages system resources and process operations. Process management involves handling active processes, including allocation of CPU time and memory. Operating systems ensure smooth interaction between hardware components and user applications for efficient computing. In this video, we'll explore the vital role of process management in operating systems, focusing on task scheduling and execution. The kernel efficiently allocates CPU time using algorithms such as round-robin and first-come, first-served. Moving to memory management, the system tracks memory allocation, ensuring each process has sufficient RAM. By implementing paging and segmentation, it optimizes virtual memory utilization for better performance. File system management oversees files and directories, enabling smooth read and write operations and storage devices. It employs file systems like NTFS and extension to organize and manage data effectively. Lastly, device management uses drivers to translate OS requests into commands for hardware control. Operating systems act as crucial intermediaries between computer users and hardware, enabling application execution and resource management. The boot process begins with the system firmware, like BIOS or UEFI, initializing hardware components. The bootloader, a small program, loads the operating system kernel into the computer's memory. Once loaded, the OS kernel starts, initializing system components and managing hardware interactions. The kernel, central to the OS, efficiently manages system resources and process operations. Process management involves handling active processes, including allocation of CPU time and memory. Operating systems ensure smooth interaction between hardware components and user applications for efficient computing.